Okay, for this question, how much energy is required to heat 100 grams of water from 50 degrees Celsius to 100 degrees Celsius? We need to do the same thing we do with all problems when we first approach them. First, we need to figure out what phases we're in at these two temperatures and if we're changing phase at any point as we move from 50 degrees Celsius to 100 degrees Celsius. So, we know that our boiling point of water equals 100 degrees Celsius. We know that our melting point of water equals 0 degrees Celsius. So 50 degrees is above our melting point but below our boiling point. So that means that at 50 degrees Celsius, water is a liquid. Then at 100 degrees Celsius, it's actually 100 degrees Celsius is our boiling point. So we're undergoing a phase change. We're going from liquid to a gas. So in this equation, with this problem, we're going to have a Q, we're going to have to do our Q equals MCAT equation for this problem for 50 degrees Celsius, but we're going to have to do our delta H, and I'm going from liquid to gas, so I need my delta H VAP. So I need my HVAP for this part of the equation. Because if I draw my little graph, it's going to look like this. Okay, this is going to be my 100 degrees Celsius, and this is going to be my 50 degrees Celsius. And I'm adding heat to the water to raise the temperature. So the first thing I'm going to do is I'm going to do my Q, and then of course at the end of the equation, once I do all of my calculations, I'm going to add my Q value to my HVAP value, my delta H vaporization value. So let's do our Q first. Q equals MC delta T. So Q is going to equal the mass of my water, which is 100 grams, times the specific heat of my water, which is going to be given to you, which is 4.18 joules per gram per degree Celsius, times my change in temperature, which is final minus initial. So 100 minus 50, which, actually do that math right here, but I just wanted you to see that it was 100 minus 50 is 50. Okay, so I plug it in, and I get 100 times 4.18 times 50, and I get a Q value of 20,900 joules. Remember, it's joules because my specific heat of water was in joules per gram per degree Celsius. So my final answer for Q needs to be in joules. Now, my delta H VAP for water will also be given to you, and it is 40.7 kilojoules per mole. So what this means is it takes 40.7 kilojoules of energy to take water from a liquid phase to a gas phase. So 40.7 kilojoules to take 1 mole of water from a liquid phase to a gas phase. So I'm not sure how much water I have is in terms of moles. I know I have 100 grams, but my delta H VAP measures things in terms of moles. So I need to change my 100 grams of water to moles. So I do my conversion, 100 grams, and I get 18 on the bottom because I find my molecular mass of water, and I know that my molecular mass of oxygen is 16 plus hydrogen is 1. I have 2 hydrogens, so 16 plus 2, and I get 18 over 1 mole. So 100 divided by 18 equals 5.5555, repeating. So I'll just do 5.56, my grams cancel, moles of water. Okay, so I have more than 1 mole. Again, 40.7 tells me how many kilojoules for 1 mole. I have 5.56 moles. So I can take my 5.56 moles, and I can actually do a conversion for this as well. And I know, so my delta H VAP is 40.7 kilojoules, because ultimately I need my delta H to be in kilojoules. So I need my moles to cancel, so it's 40.7 kilojoules for every 1 mole. So I can just do my conversion. My moles cancel, and I take 5.56 times 40.7 equals 226.292. We'll do 29 kilojoules. Okay, because my delta H VAP was in kilojoules, so my final answer needs to be in kilojoules. So now I need to take my Q plus my delta H VAP value for my 5.56 moles. But my Q is in joules and my delta H is in kilojoules. So I need to convert one or the other so that they are in the same units. And I like working with smaller units, so I'm actually going to convert my Q by moving my decimal point over 3 places. So make some of this a little smaller. So my Q value is actually going to be 20.9 kilojoules. So now that they're both in the same units, I can just add them together. So 20.9 plus 226.29 gives me, that's 20.9, gives me 247.19 kilojoules. So it takes 247.19 kilojoules to heat 100 grams of water from 50 degrees Celsius to 100 degrees Celsius. Now, the only thing that I want you to be aware of for problems like this, all right, let's see if I can move a whole bunch of stuff around here. So for problems like this, what I want you to be aware of is if you have more than one step. So if you're raising something, let's say I was raising water to 105 degrees Celsius. So I start at 50. I get to my 100 degrees Celsius. So this is my 50. This is my 100 because I have a phase change at 100. It's my boiling point. Then I'm going to, 105. So my 105 is up here, my final temperature. So then my temperature continues to rise to 105. So here I'm going to have my liquid phase, my liquid to gas phase, and then my gas phase. So I'm going to have a Q here, and my delta H VAP here. So for my Q gas phase, this is what you have to be careful of. My mass is going to be the same, so it's still going to be 100 grams of water. My specific heat is going to be the same, 4.18. But my temperature change is going to be from the beginning of my gas phase to my final temperature. So I'm not going to go from 105 all the way down to 50. I'm just going to go final minus initial. So my initial temperature in my gas phase is 100 degrees Celsius. So my final is 105 minus my initial temperature for my gas phase. So just this piece right here is 100 degrees. Okay, so because my gas phase starts at 100 degrees Celsius, and we're kind of cutting it off. They told me that we're only raising the temperature of the water to 105. So that's going to be my final. The Q of my liquid, okay, we're going to have 100 as our mass, 4.18 as our specific heat. Then we're going to do our temperature change for just our liquid phase. So our 50 is our initial and 100 is our final. So final minus initial. Because remember, I'm moving in this direction. I'm adding energy. So it's an endothermic reaction. I'm adding energy to go from 50 degrees Celsius to 105 degrees Celsius. So my QL for this phase, my liquid phase, my initial temperature is 50, my final temperature is 100. My temperature change is always final minus initial. So 100 minus 50. Just be careful. You don't want to take your 105 minus 50. That's incorrect. You need to take it in pieces. So just be careful of that. And if it helps to draw out this graph, do it just to make sure you're stopping at the correct temperature points and calculating your delta T or your temperature change correctly.